Hello everyone, my name is Pranav Tate, roll number 2006068. I am here to present a PPT of manufacturing process of steel pipe of subject manufacturing process and machine tools. Uh, First of all, we discuss about what is steel pipe. Steel pipe are long, lightweight and hollow tube that are used for a variety of purposes. They are used for water and gas supply, automobiles, heating and plumbing systems, flagpoles, street lamps and etc. Next point is design. There are two types of steel pipes, seam pipe and seamless pipe available in market. Seamed tubes are heavier and more rigid. They are used as gas transportation and plumbing purpose. Seamless tubes are typically more lightweight and have thinner walls. They are used for bicycle and transporting liquids. Raw material required for steel pipe. Primary raw material in pipe production is steel. Other metals that may be present in the alloy are aluminum, manganese, titanium, tungsten and zirconium. Manufacturing process. The overall production method are three steps. First, raw steel is converted into a more workable form. Next step is pipe is formed on continuous or semi-continuous production line. And third step involved is the pipe is cut and modified to meet the customer needs. Above are the following points involved in the manufacturing process. Ingot production bloom and slabs, further processing, pipe making and final processing. Ingot production. In this, molten steel is made up by melting iron core and choke, carbonic substance that result when coal is heated in absence of air in the furnace. Then the removing most of the carbon by blasting oxygen into the liquid. The molten steel then poured into large thick-walled iron molds. They are cooled in ingots. In order to form flat products such that plates and sheets are long products such that bars and rods ingot are shaped between large rollers under enormous pressure. Producing blooms and slabs. To produce blooms, an ingot is passed through pairs of grooved steel rollers that are stacked. These types of rollers are called two-high mills. In some cases, three rollers are used. The rollers are mounted so that the grooves coincide and they move in opposite direction. This action causes the steel be squeezed and stretched into thinner, longer pieces. When the rollers are reversed by the human operators, the steel is pulled back through making it thinner and long. This process is repeated until the steel achieves the desired shape. During this process, machine called manipulators fill the steel so that each side is processed evenly. Ingot may also be rolled into slabs. In the process is similar bloom making process. The steel passed through pair stack roller which stretches it. However, roller mounted on the side control width slab. When steel requires the desired shape, uneven ends are cut off and slabs are bloomed and cut into shorter pieces. These are the two images which shows slabs and blooms. Next is further processing. Blooms are typically processed further before they are made into pieces. Blooms are converted into billets by putting them through more rolling devices which makes them longer and more narrow. Billets are cut by devices known as flying shears. They are pair and synchronized shear that races along moving billets and cut it. This allows efficient cuts without stopping the manufacturing process. These billets are stacked and will eventually become seamless pipe. Slabs are also reworked to make them malleable. They are first heated to 2200 degree Fahrenheit it's about 1200 degrees Celsius. This causes an oxide coating to form on the surface of the slab. By the milling can long as half miles. As slab passes through roller, they become an inner and longer. Cause about the 3 minutes in single slab can convert it from a 6 in 15 to 15.2 centimeter thick piece of steel to thin ribbon that can be quarter mile long. After stretching, the steel is picked. This process involves running it through a series of tanks that contain sulfuric acid to clean the metal. To finish the rising, the cold and hot water dried and rolled up large spools and packed for transportation of pipe making facility. Next point is pipe making. Both shelf and billet are used to making pipes. Scalp is made into weld pipe. It is the first place an unwound machine as pulp of steel is unwound. It is heated. The steel is then passed through series grooved roller. As it is passed by the roller cause the edge of the scalp to curl together. This form an unweld pipe. Then steel passed by welding electrode. This device seals the two ends of the pipe together. The vent seam is then passed through the high pressure roller, which helps to create tight weld. The pipe is then cut into desired length and stacked further process. Welded steel pipe is continuously processed, and depending on the size of pipe, it can be made as fast as 1,100 feet. It approximates about 335 meter per minute. Then when seamless pipe is needed, square billets are used for production. They are heated and molded to form a cylinder shaped, also called a round. A round is then put furnace when is heated with white weight. Then since this hole is irregular shaped, a bullet shaped piercer point is pushed through the middle of the billet as it is being rolled. After the pressing stage, a pipe may be still final processing. After either types of pipe is made, they may be put through a straightening machine. They may also fitted with joints so two or more pieces of pipe can be connected. The most common types of joints are joints for pipe with smaller diameter is threading tight grooves that are cut into the pipe end. Pipe are also sent through measuring machines. This information also, along with other quality control data, is automatically slid on the pipe. The pipe is then sprayed with a light coating of protective oil. The most pipe is typically treated to prevent it from rusting. This is done by galvanizing it or giving it coating of zinc, depending on the use of pipe and other paints or coating may be used. Quality control. Next point is quality control. Variety of measures are taken to ensure the final steel pipe meets specification. For example, X-ray gauges used to regulate the thickness of pipe. The gauges work by utilizing two X-rays. One is directed at the steel of known thickness. Other is directed as the passing steel on the production line. If there is any variance between the two rays, the gauge will automatically trigger resizing of roller to compensate. And next point is the pipe are also inspected for defect at the end of the process. One method of testing pipe is by using a special machine. This machine fills the pipe with water and then increase the pressure to see if it holds. The defective pipe returns for scraps. Thank you.